Hi guys, in this video we are going to learn about equations of straight lines. So we are going to start with gradient or slope of a line. So a slope is a measure of steepness. Let me draw this so it can guide us. So this is the slope or the gradient that I'm talking about. Then here here is known as run, here is known as rise in a Cartesian plane. So here is the horizontal, while here is the vertical. Hope you know that. Here is the vertical, while here is the horizontal. This is the x-axis in a Cartesian plane, while this is a y-axis. So while finding the gradient or the slope is the ratio of vertical distance to horizontal distance. This definition will assist you to find the gradient itself. So gradient is found by vertical distance over horizontal distance. An example, let's use this as our example. Here is 5, here is 10. So the gradient is the vertical distance. Here is the vertical distance over the horizontal. The horizontal is here over 5. So our gradient is 2. Hope you have understood that. Well, in a Cartesian plane, this is known as the slope. So once you have drawn, once you have framed, so you just find here by maybe counting there. The gradient of a line from two known points. So for a line passing through 2 points, let's say AXY and BXY, the vertical distance, let me plot that first so that you can understand it better. So for this, I've plotted it already. Remember, this is our y-axis and this is our x-axis. Remember also, this is our horizontal plane and this is our vertical plane. Keep that in mind. So finding the gradient in this case, we have to take our horizontal we'll have to take our vertical distance. Remember, the gradient is vertical distance over the horizontal distance. So we'll need to take the changes in our vertical distance. Change in vertical distance over change in horizontal distance. So for this case, it will be y2 minus y1 over x2 minus x1. So this will be our gradient. So I'm going to do an example regarding that. Determine the gradient of the lines passing through the following points. So for our point 1 is so our first point is A, it is passing through 2, 5, and B, 4, 6. So for our gradient, remember it is y1 minus y2 minus y1 over x2 minus x1. So for this case, let's take our A as x1, y1, and our B as x2, y2. So for this case, our y2 is 6 minus our y1 is 5, divided by our x2 is 4 minus our x1 is 2. So 6 minus 5, that is 1 over 4 minus 2, 2. So our gradient is the same as 1 over 2, or you can write 0.5. Let's move to the next subtopic, equation of a straight line given 2 points. So let's do this example so that you can understand better. Find the equation of a line passing through the points. So that is our point. Remember, we are finding the equation of a straight line passing through this point. So in this, we have the procedure. Find the gradient first. Find the gradient. If you use this procedure, your work will be much more easier and you'll even achieve all the marks. Then consider a general point. In this case, we have A and B. We can consider one of the points. So let's take it to be A for our case. Then using the general point, write an expression. That is our next step. Write an expression for finding the gradient. And equate to the gradient obtained in step 1. Our last step, simplify the expression. With these 4 simple steps, you will be able to find your equation and obtain all marks. So in this case, we are going to find the gradient. Let's take our A to be x1, y1, and our B to be x2, y2. So our gradient, remember, it is y2 minus y1 over x2 minus x1. In this case, our y2 is 10 minus our y1 is 4 over our x2 is 8 minus our x1 is 5. 10 minus 4, that is 6, over 8 minus 5, that is 3. In this case, our gradient 6 divided by 3, that is 2. This is our gradient. So we have already found our gradient. Consider a general point. So a general point, and remember we were supposed to use our A as we noted here, our A. So let's take this as our x1, y1, and this as our x2, y2. So y2 minus x1 divide by x2 minus x1. Then we equals this to our gradient. Write an expression for finding the gradient and equate to the gradient obtained in step 1. This is what we have already done. So we need to simplify this equation. So we'll multiply here by 5 minus x and here by 5 minus x, so that this 5 minus x cancels itself in this side. We remain with 4 minus y is equals to 2 into 5 minus x. So 4 minus y is equals to 10 minus 2x. So in this case, it will be 4 minus y equals to 10 minus 2x. Let's bring this 4 into this other side. So it will be negative y is equals to 10 minus 4 minus 2x. Negative y, let me write this in a clear paper so you can understand better. So it is 4 minus y is equals to 10 minus 2x. Negative y is equals to 10 minus 2x. This 4 we have brought it to this side, so it will be minus 4. Negative y, is equals to 10 minus 4, that is 6 minus 2x. Let's divide this by negative 1 so that we remain with a positive here. So it will be y is equals to negative 6 plus 2x. So if we write this in the form of y is equals to mx plus c, this is what you'll see most in your paper. So this m stands for the gradient, while this x is the x you see here. This c is the constant, this, and this y is the one that you see there. So y is equals to, we bring the mx here, so that is 2x. Remember, it doesn't have a negative, it is just a positive. So plus c, this is a negative, so it will be minus 6. So when you are asked to write the value of m is equals to 2, while the c is equals to negative 6. Hope you have understood. See you in my next